implicit differentiation. So in the first equation, we have 2x plus 4x to the fifth divided by x minus y equals to 6x. So if you just go ahead and differentiate both sides with respect to x, you will have to do a quotient rule on the left hand side. I would like to avoid doing the quotient rule, so to do so, I would like to multiply the denominator on both sides. So now we have 2x plus 4y to the fifth equals to 6x times x minus y. So once you distribute the 6x on the left hand side, you can avoid a product rule. Actually, I should not say you have to avoid the product rule, because after you distribute, you have 6x squared minus 6xy. So there is a product rule on the 6xy. But you might have less job to do if you just do the 6xy instead of doing the 6x times x minus y. So you have to do a product rule anyway, but the job may be smaller than doing the 6x times x minus y. And then on the left hand side, so let's just write 2x plus 4y to the fifth. So now we are ready to take the derivative on both sides. So I am going to move this a little bit to the right, so I have space to write the dx. So we are differentiating both sides with respect to x. Alright, the derivative of 2x is equals to 2. There is no need to write dy dx because this is with respect to x. But when you do the 4y to the fifth, so you bring the phi down, so you have a 20 y to the fourth. So since this is a dx and you have y as your independent variable, then you have to do this. We treat y as x, and then we take the derivative, so we carry the phi down and then take phi minus 1, and then at the end of the y to the fourth, you have to write down dy dx. So you have to write dy dx, so this is implicit differentiation. And then on the other side, the first term is x, so you have a 12x to the first, no need to write dy dx, and then minus the 6xy. So this one is a product rule. So what's the product rule? The product rule is, so product rule is fg prime plus gf prime, right? So let's put this in a parenthesis. So fg prime, so we have to do f, so which is 6x, the derivative of y is equals to 1. So since this is a y, we need to add a dy dx. And then gf prime, so g is y, the derivative of 6x is equals to 6. Alright then. So the next step is we will have to distribute the minus, and then we put all the dy dx on one side and then the rest on the other side. So we have 2 plus 20y to the fourth, and then dy dx equals to 12x minus 6x dy dx, and then minus 6y. So let's keep this on the left and then move this to the left, and then everything else goes to the right. So we have 6x plus 20 y to the fourth, and then dy dx, that is equals to 12x minus 6y minus 2, and then we factor out, oh, I forgot to write a dy dx. Okay, so I'm going to correct this and then write 6x dy dx, and then we factor out dy dx. So we have 6x plus 20 y to the fourth, and then equals to the right hand side. And then now we divide the parenthesis on both sides. So at the end of the day, our final answer is we have the left hand side divided by the parenthesis, which is 6x plus 20 y to the fourth power. And then we box that as the final answer. Alright then, so this is the end of the first problem. So let's move on to the next one. So the next one, we have square root x times y. So there is a chain rule in there, right? So this product rule, I mean, is in this parenthesis. So let's make that clear. And then the next one, we have a square root of x times y equals to x to the fourth plus y squared. So definitely there is a chain rule in the square root. So let me move this to a little bit to the left, so I have more space for myself. So for the first one, we have to do a d dx, and then this is xy raised to the 1/2, and then d dx x to the fourth plus y squared. All right, there is a chain rule on the left hand side. So first of all, we bring the 1/2 down, right? So we bring the 1/2 down, and then we have xy, and then raised to negative 1/2, and then by chain rule, we have to take the derivative of the parenthesis, which is xy, right? So how about this? We write one extra step, so we have to take the derivative of the inside, and then on the right hand side, bring the 4 down, 4x to the third, and then plus 2y. Did I miss anything? The answer is I am missing a dy dx because this is with respect to x. So you have y, then you read this to yourself. You treat right as x, apply the power rule, and then put dy dx at the end. Okay, so this, let's write this down. This is a chain rule. And then for in this chain rule, there is a product rule. So how about this? I should point this to the multiplication chain rule. And then inside the chain rule, we have a product rule. Okay, so we have 1/2 and then xy to the negative 1/2. So let's apply the product rule. The product rule is fg prime plus gf prime, right? Okay, so fg prime, so f, and then the derivative of y is equals to 1, but you just use a y, so you have to add a dy dx to it, and then plus gf prime, so g is y, the derivative of x is equals to 1, and then you copy the rest. Okay, we need a distribution on the left. So what do we have there? We have this, right? So we have a x, and then we have a 2. The negative 1/2 is this a square root, and then we have a dy dx, and then we have a y times that. So we have a y, and then this is 2 square root of xy, right? Looks good. And then 4x to the third plus 2y, and then dy dx. Who stays on the left? So this term stays on the left, and then this term stays on the left, and then everything else goes to the right. So we have x divided by 2 root xy, and then dy dx, and then minus 2y dy dx equals to 4x to the third, and then minus y, and then 2 square root of xy. All right, so once you divide this, so here is the next thing. So you factor out dy dx, right? So this one is a x divided by 2 root xy, and then minus a 2y, right? And then this one, once you perform the division, then you might have a complex fraction. So how do I avoid the complex fraction? So let's get a common denominator. So the common denominator is I would need this on the bottom. So that doesn't look like a y, right? So this looks like a y. So if you multiply the 4 by that, then you have an 8 x to the third, and then root xy. And then how about the other side? The other side, dy dx. So this one, what if I do this? So this will be x minus 2y, right? So 2 times 2 is equals to 4, 4y root xy then. Okay, so that is equals to 2 root xy, and then we have ax to the third root xy minus y. So once you perform the division, then you have one fraction multiply the reciprocal of the other fraction. Ax to the third root xy minus y divided by 2 root xy, and then you multiply the reciprocal of the left hand side. So you have 2 root xy, and then x minus 4y root xy, right? And then I can see that these two terms, they got cancelled completely, and then the rest, I don't think you have to simplify the rest. So I will just take this dy dx, that is equals to ax to the third root xy minus y divided by x minus 4y square root xy. So I will just take this as my final answer. If you insist to do a little bit of simplification, you can. This one you have x to the third, right? And then times root xy. So you can break this down as x to the third times x to the 1/2, and then times square root of y, because they both share the square root. So because they both share the square root, you can take this, you can take that as square root of x times square root of y. And then you add the 3 and the 1/2, so that is a x. So this is a 2, 6 plus 1 is equals to 7, and then times root y. I don't see the reason of doing this. If you want to do that, that's fine, but I will just take this as my final answer. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you are new to the channel. I will see you all in the next one. Signing out.